Hello everyone. This is the second part of the last video wherein we started speaking about services of 5G, which we are expecting in the future days when the 5G will be implemented. So I was able to discuss about only 3 different services in the last presentation or last video. So I'll be having 3 more different services which are quite expected here, which are services which we are actually need with respect to the operation here. The first one that I'll be speaking about is ultra-reliable machine-type communication. Last time we saw the massive machine telecom communication. Here we will be speaking about ultra-reliable, where reliability is quite more important rather than having with the connections with respect to machines. So we discussed in the last video that when we are speaking about massive machine type communication, we were in need of providing a service which will be quite more efficient with respect to its energy, which will consume very low energy, because we will not be able to change the batteries or the power supplies, cannot provide power supplies to more amount of sensors wherever we connect them. So here it is not about the energy, instead we will be speaking mostly about the reliability. So the information that will be passed from one point to another point must reach in time without any delay, because it would be causing a lot of disasters if it is delayed. If you observe, we have got 2 different examples that we have considered for this ultra reliable machine type communication. One is that road safety and traffic efficiency, to maintain that. The other one is that industrial manufacturing. So industrial manufacturing, we also can consider that as an example for massive machine type communication also. But in some of the applications wherein industries which will be working more about precisions and they want their machineries to work very precisely with respect to time management and all that, then this ultra reliable machine type communication is quite important. The other one that we are speaking about, road safety and traffic efficiency, does need this ultra reliable MTC, without which it would be very tough for us to maintain the machine type communications in terms of traffic and road safety. Because if suppose there is a car coming and we have an information about the other coming from the perpendicular road, if you are not getting proper information in time, then anything could happen there. So it's a future thing that we are speaking about. We are bringing in autonomous vehicles and they are driving the vehicles by themselves, or a lot of different VANET kind of networks that we are trying to build, wherein we will be able to understand the movements of different vehicles sitting at our own vehicle. So all those things, in all those kind of things, this ultra reliable MTC is quite more important. So we will speak about that. What is those applications that we are supposed to consider under this road safety and the industrial manufacturing? The first thing is that with respect to road safety, we have multiple communications. That is one vehicle to vehicle, vehicle to pedestrian, vehicle to infrastructure, and then vehicle to anything, which can include everything. So vehicle to anything will come up with many different things, right? So that vehicle to anything should also communicate for anything other than the regular things, whatever we spoke, like vehicle, pedestrian, infrastructure. Let us say anything, because anything could be improvised in future. So vehicle to vehicle, to know the distance between 2 vehicles, or knowing about a vehicle that is traveling in any perpendicular roads or parallel roads where there could be a collision that could be occurring in future or something like that. So for that is important. Vehicle to pedestrian. So pedestrian, identifying the pedestrian trying to cross a road or running towards the road or something like that, that could be very much helpful. Infrastructure, we will be knowing about if suppose there is a vehicle that is coming out from a very perpendicular curve where we have a very big building in that corner. So infrastructure would be helping us out with respect to knowing the vehicles. The other thing is that industrial manufacturing, wherein we will be having stationary equipment, or we may also have some rotating equipment, or sometimes we will be having some moving parts. So for all these operations, we need autonomous transport robots. We are in need of these autonomous transport robots, where the robots will be able to pick elements from one point to another point, and making sure that proper elements are delivered to proper points. So for all those things, we need this ultra reliable MTC. Then also we speak about sensors that are deployed in any equipment or any different parts with respect to monitoring any different machineries. So when we are monitoring, we need this precision to be quite more important. So the other service that we will be speaking about in this video is Dynamic Radio Access Network. So we have spoken about this radio access network or dynamic radio access network with respect to the 5G and its operation earlier. Here we are considering it as a service because 5G will be trying to give connectivity to multiple items. I don't say items, like many different products. So not just your mobile phone or for your call purpose or data purpose, it is also giving a connectivity with respect to many other things like the autonomous vehicles or autonomous robots or anything it could be. Right? For all these reasons, whenever we have this dynamic radio access network, it will be quite more helpful for us to know what kind of network to be used for what purpose. And whenever we are trying to travel between any two networks, the other network should also be able to give the services as same as that of the previous one. So when we speak about this, some of the features that we are supposed to consider with respect to 5G are wide coverage. So trying to reach out a bigger area. Then ultra dense network. So density, when we are speaking about any big hall or any ground where we will be having too many number of users at a time. So that is ultra dense network. Then nomadic nodes. So we will speak about nomadic nodes. Then beamforming, wide area coverage, and then we speak about reduced signal to noise ratio and device to device communication. So we will all see that how the connections or communications are happening and all that. So this is about addressing different elements that are quite concentrated on the same thing, like increasing the signal to noise ratio. So the more the signal to noise ratio is, we will be having more efficient network, right? So in the dense urban environments, this ultra dense network solution will be quite more important, and we will not be sometimes we will not be able to use MIMO there. Sometimes we will be able to use MIMO there with respect to suburban or in some village areas wherein we will be having a mass users at the same time, like festivals or some celebrations and all those things. So when we speak about this ultra dense network, it will be trying to give or increase the network capacity or network densification. Then it will also be able to, we will be able to deploy this outdoor or indoor, and it will always target users so that it can provide a data rate on an order of 10 Gbps, and then it will be able to operate standalone or with respect to capacity boosting. The next thing that we'll be speaking about is moving networks. That means any node which will be having any wireless access, it can provide us that communication capabilities. So these nomadic nodes are those communications that are generated by a vehicle that can be utilized as a node which can give some temporary access to anything. So your vehicle access point can be used so that it can provide service to the users who are there inside the vehicle, or quite sometimes outside also. Then we speak about antenna beams, increasing or improvising the efficiency of antenna beams, or wireless devices as temporary network nodes. We will be trying to increase it. Sometimes your mobile phone, if it is there in any range, trying out to reach any network, so sometimes your mobile phone can also be transferred to make a node and give a service to another person who is quite 10 meters away from you. Like the other one is device-to-device communication, which is quite more important. We need that device-to-device communication. Then activation and deactivation of nodes. It will be able to operate it very well. Then interference identification and mitigations. Then mobile management. So that is important. The last point that we'll be speaking about is wireless backhaul. This backhaul will be helping us in providing services in two different types. So you can observe that in the diagram, we have a bus. The bus has got two different customers who are using the service now at that moment. And at that moment, if you observe that we have got two users, one user who is using the service directly from the network, right? At the same time, there is another person who is using the service from that access point we have in the vehicle. So this vehicle is communicating to the node, E-node. At the same time, the vehicle is also giving service to the user who is there inside the bus. This is the speciality of creating a backhaul or wireless backhaul, so that we will be able to make sure that the connectivity for everybody is properly served. Okay. The next thing that we'll be speaking about is lean system control plane. So this lean system control plane is important because it is the actual reason which holds all the three of the applications that we have spoken earlier in a proper line. That is your ultra reliable mobile machine type communication. Then we also spoke about the mobile broadband, extreme mobile broadband, and massive machine type communication. All the three are held together and on a base which is nothing but your lean system control plane. So this has got like three different 5G services which we are supposed to always keep in mind when we are speaking about it, which actually works mostly on spectrum flexibility and energy performance. We see how it actually works. The purpose of using this lean system control plane is to provide a common system access so that all three different types of applications get connected to the same point, then provide service and specifying the signaling so we'll be able to do it properly, then support control plane, then integrated different spectrums and site distances with respect to mobile broadband, and ensure energy performance. Then we have two more different applications. One is that localized contents and traffic flow. Sorry for this. So we have spoken about this already, like having data in a common or local node, trying to hold the usually using data on a single node, which holds the data locally. So we'll be trying to reduce the complexity for the host at the other side, server at the other side. So we have three different types of communication here, where is one call is moving from this device to the network and then to the server, coming back from there and going to the mobile phone. This is one type. The other type that we have with respect to this is the other one we can speak about is the other one from the mobile phone going to the base station and from base station to the device. That is another type. The other one which we have is device-to-device communication, which we have spoken directly, right? This is your device-to-device communication. So all three types can happen. And this also has got anti-trombone, which is actually between two nodes. We spoke about all three that. Then we have got device-to-device offloading, then the server and contents close to the radio. All these things will be happening with respect to that. The last thing that we'll be speaking about is Spectrum Toolbox. Spectrum Toolbox plays a very important role with respect to the services of 5G because it has to give service to three different types of communication. So we already marked about those things, right? So we have got Spectrum separately for our extreme mobile broadband, which will have to be serving somewhere around a frequency of 6 GHz with a bandwidth of hundreds of megahertz, sometimes more than 1 GHz of bandwidth would be required because it will be given for services with respect to a bigger utilization. Then comes for machine type communication or massive machine type communication, wherein it can operate sometimes below 6 GHz or sometimes very below 1 GHz because we cannot expect all the devices or sensors to be working at a very big frequency. And it may have to give a bandwidth of 1 to 2 megahertz. So that's quite enough with respect to passing some sensor data from one point to another point. Then we have ultra reliable machine type communication, where we will be speaking about high reliability and low latency. That is the importance that we give. So to have that low reliability, to make sure that there is no low reliability, the signal bandwidth can be increased. So we increase the bandwidth of the signal and we reduce the transmission time. That's how we will make sure that latency is reduced. Then the exclusive spectrum access and very high priority in spectrum access is essential with respect to the provisions that we are supposed to give. So what are the properties that we have? The properties are like it enables the operation in widely distributed spectrum bands, so which operates at a very high frequency and also at low frequency. Then it facilitates different sharing scenarios. So we may have to share different frequencies for different operations. That happens with respect to solely alone it can operate, or in combination of different frequency also it can operate. Then it will be able to facilitate with respect to using a very small or a very large bandwidth also. Spectrum Toolbox will be so intelligent that it can give a flexibility or flexing flexibility with respect to air interfaces, giving small or large bandwidth as per the requirement. Then it can adopt different rules for different services. So as we spoke about, for broadband is different, or machine type communication it is quite different. So that actually specifies the services of your Spectrum Toolbox. So these are the things that we spoke about, the services that we are expecting from 5G. And I hope I have tried to give some basics and architectural information about 5G till now. And in my upcoming videos, we will be speaking more about 5G and other than that, how the bandwidth and different technologies have been implemented from 4G and also to 5G. Thank you for watching the video. don't forget to subscribe to my channel so you can watch different videos